Okay, in this recording, we'll be working on some finance questions and learn about this application of exponential functions. So I'm going to share my screen and we'll go into my open math unit 6.
Okay. Wrong way. I don't think so. Okay. I think just loaded them down and then something over. I think. You got it.
Can you both see my open math screen?
Yes.
Yes.
Okay, so we'll start with question number 27. We have an investment of $4 is earning 6% interest per annum compounded annually. If the value V of the investment after T years is given by V equals 4 times 1.06 to the T, then T written as a function of V is which of these? So they just want us to solve for T and they gave us the equation already, which is really handy. So what I'd like to do, first of all, is divide both sides by 4. So we want to get the T alone on one side. So we'll divide both sides by 4 here. 4 divided by 4 is 1. And now we want to get rid of that T in the exponent position. So what I'm going to do is take both sides, take the log of both sides, and I'm going to do it as log base 2. And you'll see why in a minute, but you can also tell right here in all of the possible answers, they're using log base 2.
I don't know whether I'm gonna leave any string in our computer. I don't know if I leave any string or what took place. I don't know how it's put together.
Oh, yeah, you want to just grab a new one. And we want to do the same thing to both sides so it stays equal. So we've got the 1.06 to the T here. Now we'll use our log properties to simplify. When you have a division with a log, you can expand that to a subtraction of 2 different logs with the same base. So we'll have log base 2 of V here, 58.
Sorry.
No, you're fine.
Yes.
Excellent, thank you. Minus log base 2 of 4. You remember that from class? That when you've got this quotient, you can expand that into subtracting the 2 logs. And then on the right-hand side, we can take this exponent and move it down to the front. That's the power rule. So if you're looking at your list of properties, we're using the quotient rule here and the power rule here. So this becomes T times log base 2 of 1.06. And now we're solving for T, so we'll just divide both sides by log base 2 of 1.06. And now you can choose which multiple choice question was the right answer. If you were in my first class on Wednesday, the one that ends in 8-9, I started this problem, but I didn't finish it. So now you can see the rest of the story. So the log base 2 of 1.06 divided by itself just cancels to 1. So we're left with T equals all of this. So it would have been, oh, we're almost done. There's one more thing we can do to simplify. We can rewrite this 4 here as 2 squared. And then we can use a log property to simplify that. So I'm going to erase this 4 and replace it with 2 to the 2nd power. And now the log base 2, this log base 2 and that 2 is going to cancel. That all simplifies to the number 2. So we're left with log base 2 of v minus 2, which you can see here, divided by log base 2 of 1.06. So it would be this answer right here. What questions do you have for me about that problem? Can everybody hear me okay? I am not seeing the chat box right now. Thank you. Let's see if I can pull it up.
Yes, I can hear you.
Okay, and I can see the chat box now. I just got it pulled up. Okay. Just stop me if you have any questions as I'm going through these. All right, the next problem that we want to work is number 28. You deposit $2,000 in an account earning 2% interest compounded monthly. How much will you have in the account in 5 years? So if you look at your list of formulas from the chapter 6 formulas, it's found in Blackboard, start here. This is going to be a future amount question using the compound interest formula. And there's a big clue there. It tells us it's compounded monthly. So you want to be thinking, well, compound interest formula or the future value formula. But here it's asking how much will you have in 5 years? So you want the one that's solved for A, you want the future amount. So that formula for compound interest on a future amount is your future amount equals the principal times 1 plus your interest rate given as a decimal divided by the number of compoundings per year, all raised to the NT power. And T is always in years. Okay, so start putting in the numbers for me. Sorry, I forgot to do that. But he knows you're okay. There's soon. Did you lay down and try to sleep? Did you decide to watch something? Probably takes some time to see.
All right, this one, you all make.
Okay. Yes, the P is the 2,000, the interest rate would be 0.02. Time would be, the T would be 5, not 15. And N is the number of compoundings per year. And since it's compounded monthly, that would be 12 times per year. Okay, so let's go ahead and put this into Desmos now.
So what is the N again?
It's the number of compoundings per year.
So what would that be exactly then?
So since it's monthly, that would be 12 times per year. So let me go into Desmos. Does that make sense? The N would be 12 if it's monthly? If there's 12 months in a year. So you would take 2,000 times 1 plus 0.02 over 12. And then when you're raising it to the NT power, put the NT in parentheses so that doesn't mess up what the power is. So it was 5 years, that's your time, your T, and your N is still 12. So that means your future amount will be $2,210.16. Does anybody have any questions on that one, on number 28? Okay. On our next one, this one is a little different because this person is saving, Tabria would like to save $5,900 regularly at the end of every 3 months. She's gonna save $5,900 for the next 4 years in a savings account. But it's not just going to sit there at $5,900 every 3 months. It's gonna grow. It's gonna earn 3.9% compounded quarterly.
Well, we do.
So we're supposed to find the accumulated
Can you
value.
go back to 28 by any chance? Cause it's still saying that I'm getting it wrong, but my numbers are different than what you have on the screen.
Okay, can you tell me your numbers?
2,000,
Okay,
and then the interest, 4%, so 0.04.
yeah,
You what?
that's right. And
Sorry, my screen just
is
went,
it,
okay.
is it compounded monthly?
Compound monthly and then in 15 years.
Okay, so that's why you had 15 in the chat box.
Right.
So you would put 15 for your T. And you said it's compounded monthly, that's 12 for the N. So it should be $3,640.60. Is that what you're getting?
That's what I put the first time, but now I'm getting 364 and 6 cents.
And double check your principal, is it exactly 2,000? Are you looking back at your original question?
Yeah, I'm trying to fix it in Desmos because apparently I didn't put it quite. I'm having a hard time doing the 12 and the 15.
If you need me to, I can show you how I entered everything. With the keypad. So there's 2,000.
Okay, I got that now, but I swear that's what I just put in. That's why I had in the first time and it said that it was wrong.
It could have just been a typo.
Well, now I'm out of tries.
Did you get it right this time?
No. That's why I'm like, I need help. I keep getting the wrong thing. And
Are you getting $3,640.60?
that's what I'm getting now. And I thought, I'm pretty sure that's what I got the first time, couple times, but I've used my 3 tries. So,
Okay, I'll go back in and have a look for you.
okay.
And if you got it right, I'll give it to you. Let's see, was that number 28?
Yes.
Okay. All right, so let's move on now. We have the situation where the person is saving $5,900 at the end of every 3 months for the next 4 years in a savings account, earning 3.9% compounded quarterly. And what we call this is an annuity, when they're saving the same amount every month and so on. So there's some things that we can identify here with this annuity. the $5,900 at the end of the 3 months that they're saving, we call that the payment. So we're gonna identify our payment as 5,900.
But see, the problem is just this big.
And our interest rate is 3.9%, so we're gonna put in 0.039 for that. Notice that it is compounded quarterly. So that means 4 times per year. And our time is 4 years. So jot those numbers down. Those are the 4 things that you're gonna need to put into the annuity formula. And now I'm just gonna click right here to show you the formula. I'm gonna be using this formula right here. Now, the I is standing for the periodic interest rate, which is the R divided by the N. So the 0.039 divided by 4. So please jot down this formula and then we'll put it into Desmos together. And for sure, you'll want to have this formula down on your note card for when you take the test, as well as the compound interest formula that I showed you before. Any formulas you need for the homework, you should have them on your note card for the test. Okay, so does everybody have this formula written down, or you took a picture or screenshot or something?
Yes.
Okay, so let's go ahead and put that into Desmos now. Okay. I'm gonna save multiplying by 5,900 till the end, because you've got all this other stuff that you have to take at times. So the first thing I want to do is the 1 plus I, which is that interest rate divided by the number of compounding. So the 0.039 divided by 4. And that is raised to the NT power. So it was 4 years times 4 compoundings per year. And then we had to subtract 1 off of that. And that is all the numerator of our fraction. So I'm going to put a parentheses around this entire numerator. There's that extra set of parentheses. Okay. And now I am going to hit divided by the I, which is again 0.039 divided by 4. Okay, and now we're going to take the whole thing times 5,900. Which gives us $101,627.28. Okay, so that's our first. That's the first question in that. And then the second question that they asked is, what would be the amount of interest earned? So this is the total amount, the total value in the account. But let's compare that now to the $5,900 that was saved 4 times a year for 4 years. So 5,900 times 16 is $94,400 was put in. So let's subtract these now to find out how much of that is interest. Trying to get this out of my way. So if we take $101,627.28 minus 94,400. Keep in mind that Desmos doesn't recognize the commas. That shows you that $7,227.28 was the interest earned. Okay, that was question number 29. And now we're ready for number 30. Okay. Oregon Investment Company borrows $30,100 from a bank at 2.52% compounded annually for 2 years and 8 months. How much will the accumulated value of the loan be at the end of the term? So we need to know the future amount, so we'll be using that compound interest formula again. So our amount, and I'm gonna just put this into Desmos, but let me write down these numbers before we get there. Our principal is $30,100. Our interest rate we'll put in is 0.0252. Time is 2 years and 8 months. And we have to do that just all as a decimal. So we need to take 8 divided by 12 to get that decimal for how many years. And it's compounded annually, so N is just 1. It's only compounding 1 time per year. Okay, so now putting that into Desmos, we have our principal times 1 plus R over N, so 0.0252 over 1 raised to the NT power. So N is 1 and our T is, let's see, it was 2 years and 8 months. 8/12 will be let's see, 8 divided by 4 is 2, 12 divided by 4 is 3. So it's 2/3, that's gonna be 0.6 repeating, so 2.6 repeating. And they don't like the comma that I put in there. Okay. So that's giving us a future amount of $32,165.43. And let me just write down what I did there. In terms of the 2 years and 8 months, you would have to take the 8 months divided by 12 to see what fraction of a year that is. So that's the same as 2/3. And if you divide that out, it's 0.6 repeating. So it's 2.6 repeating years. Okay, and now we just need to see what else they want. How much interest will be charged on the loan? So if the amount borrowed is $30,100, but the amount paid was $32,165.43. So we're gonna need to take that. And we'll subtract off the $30,100, which is how much was borrowed. And so now you can see $2,065.43 is the amount of interest that had to be paid. Okay. So that is number 30. Let's move on to number 31. Josephina deposited $20,400 in a growth fund at 3.95% compounded semi-annually for 9 years and 2 months. Calculate the maturity value of this amount at the end of the term. So again, we want the future amount. And for semi-annually, that is twice per year. Our N is 2 times per year. And for 9 years and 2 months. So to figure out that time, we're going to need to take the 2 divided by 12 this time. So I'm going to jot down these numbers and then we'll go into Desmos again. Time is 9 and 2 12, which would be 9 and 1 6.
So someone is.
Yes.
And I'm just gonna do the 1 6 right now, so we have it in our mind. So it's gonna be 9.16 repeating for the time. All right, so let's go ahead and put in our principal. It's $20,400. Tell me if I got the numbers wrong. Times this is our compound interest formula. 1 plus 0.0395 divided by the n of 2 raised to the nt power. So the 2 times 9.16 repeating. And I put in a comma again. Let me take that out. So we have a future amount of $29,197.67. Okay, and then we're supposed to calculate the amount of interest that was earned. So we just need to take off the amount that was deposited. So take off the $20,400 from that. So we've got our 29,197.67 minus. How much was it again? I don't remember. $20,400. So that gives us interest of $8,787.67. Okay. All right, so now that takes us to number 32. A vehicle purchased for $32,500 depreciates at a constant rate of 4% per year. Determine the approximate value of the vehicle 10 years after the purchase. Okay, so we're depreciating 4% per year. So our first year, we would have to take off 4%. Let's just go into Desmos. We need the approximate value of the vehicle 10 years after purchase. So we have 32,500 was our original amount. And if we take off 4% of that,
we're gonna connect that to the.
so we'll have to subtract
There's a whole lot of.
4% of 32,500. Now we're at 31,200.
But they don't go.
But instead of doing that, what I want to do is I want to factor out the 32,500 here so that it will look like 32,500 times 1 minus 0.04, which is really 0.96, and you can see it's the same amount. Do you see how I did that? I pulled the 32,500 out of both of those. So it became 1 minus 0.04, in other words, 0.96. And then, for the next year, we'll take off 4% again, so we're just taking it times 0.96 again. And so on, the next year times 0.96 again, and this is going on for 10 years. So it looks like after 10 years, it'll be $21,607.06. Let's just verify that. Yeah, and it wants it rounded to the nearest whole number. So that would round to $21,607. Okay, so that was the formula. All right, moving on to number 33. We are finding the final amount of money in an account if $5,900 is deposited at 5% interest compounded semi-annually and the money is left for 5 years. This is similar to the ones we already did with the compound interest formula. So I'm going to just move on and see if we have any different ones. You need to find that future amount. On this one, 34, you deposit 5,000 in an account earning 4% compounded monthly. How much will you have in the account in 5 years? So that one again is your compound interest formula. And question 35, you deposit 4,000 in an account earning 6% interest compounded continuously. How much will you have in the account in 15 years? Okay, this one is a little different. We have compound interest, but instead of telling us how many compoundings per year, it's just saying it's compounded continuously. So if you look at your formulas, the future amount for continuous compounding is the PERT formula. The future amount is principal times e to the RT power. So your future amount equals the principal times the number e raised to the RT power. So let's go ahead and put this into Desmos, but I'm going to jot down the numbers before I go over there. Okay, so we'll go in and we'll put in our principal is 4,000 times the number e. So you just type the e key on your keyboard, and you're going to raise that to the RT power. And R was 6%, so we'll do 0.06 times 15. So that gives us $9,838.41. Okay. Now, did you want me to go back and go through those last two, these two problems, 33 and 34, or do you just want to do those on your own?
Would you mind going through those two, 33 and 34?
Yeah, those are both the compound interest formula where you have A equals P times 1 plus R over N to the NT power. Let me just jot down our numbers here. So for number 33, we've got $5,900 at 5.5% interest, compounded semi-annually. So N equals 2 twice a year. Our time is 5 years. And on problem 34, our principal is going to be 5,000. Our interest rate is going to be 4%. Compounded monthly and will be 12, and it'll be 5 years. Time is 5 years. Okay, so let's go ahead into Desmos and we can do these quick. So we're going to take For problem 33, we've got our principal of $5,900 times 1 plus 5.5% interest would be 0.055 divided by an N of 2, arrow over and raise that to the NT power. So 2 times 5 for 5 years. So that one will be $7,738.74 after 5 years. And for problem 34, we have a principal of $5,000 times 1 plus an interest rate of 4% over the N of 12. And we're gonna raise that to the NT power. So 12 times 5 years. Gives you $6,104.98 after 5 years. Okay, are there any other questions that you have for me?
I didn't